So we have a survival model, which is looking at a patient and outputs the survival function, which is the probability that the time to an event is greater than small t, where the small t could take on any value like 1 year, 5 years, 10 years. So now we can graphically represent the survival function, where on the x-axis we'll have our time, and this time could be days, months, or years. Let's say in this case it's months, and on our y-axis is going to be the survival probability at that time t. So we have time t here, and this is going to be s of t. Let's talk about a few properties of the survival function. So the first property is that the survival at any time u is going to be smaller than or equal to survival at any time v if u is greater than or equal to v. So what does this mean? Let's first pick u to be 80, and we know 80 is greater than or equal to 20. And we can read off on 80 our survival probability was 0.17, and our survival probability at time v, which is 20, was 0.89. So this holds true, we see with this example. And what this translates into is that as time goes on, as time increases, the survival probability should never go up. It can either stay the same or it can go down. The second property is that the survival function usually starts off with a survival probability of 1. There are cases where it doesn't, but we'll mainly focus on this. The second property is that as time extends on to infinity, our survival probability should get to 0. And so our survival function should start at a probability of 1 and eventually get to 0. So with that knowledge in mind, let's check out which of these are valid survival functions. So remember the two properties of the survival function. The first one's going to be as our time goes on, we need a decreasing survival probability. So here we can see that as time is going on, our survival probability is actually increasing, so this cannot be a valid survival function. If we look here, this doesn't fulfill our second property, which is that it should start at 1, so this one isn't a valid survival function. This particular survival function is going down as time is going on and starts at 1, so this seems to be a valid survival function. This one over here also starts at 1, seems to be going down. Notice that here it gets to 0. Now, this might initially seem like not a survival function because it doesn't wait till infinity to get to 0, but that's all right. It will stay at 0 as time goes on, and so this is also a valid survival function.